Hello friends, today I will discuss about differential relay testing mainly for Micom P643. Before going through this video, you are requested to please go through my channel and do subscribe my channel and also press bell button for notification for videos to be uploaded in future. Micom P643 has a dual slope characteristics as shown in this figure. Initially, for the range of I bias 0 less than I bias less than IS1 by K1, it has a ID must be, that is differential current must be greater than IS1 for going to the operating region. After that, it has a slope of K1 up to a value of IS2, and beyond IS2 it has a slope of K2, and it has a high set value as shown is in this diagram. Before starting of the testing of differential relay, you must have to go through the system configuration of the Micom P643 relay. In this figure, you can see the reference power S is the 50 MVA of the power transformer. HV connection is Y type, HV grounding is grounded, HV nominal voltage is 132 kV, HV rating is 50 MVA, percentage reactance is 10%, LV vector group is 1, that is it is YD1 type, LV connection is delta, LV nominal voltage is 33 kV, LV rating is 50 MVA. Now, if we give the general system configuration, then it will automatically calculate the matching factor for HV and LV side CT. Here HV CT ratio is 300 by 1 and LV CT ratio is 1000 by 1. CT1 is the HV CT ratio and CT2 is the LV CT ratio. The matching factor will be calculated by relay. For CT1 is 1.372 and for CT2 is 1.143. For matching factor for CT1, that is for HV, is equal to CT ratio for HV side divided by HV full load current. Since we can get the HV full load current from the data provided by the relay is 218.69 ampere and HV CT ratio is 300 by 1. We can get the matching factor for CT1 equal to 300 by 218.69, which comes to 1.372. Similarly, for matching factor for CT2 is equal to LV CT ratio by LV full load current, that comes to 1000 by 874.79. That will comes to 1.143. Now come to the setting part of the differential protection. Here IS1 is set as 0.2 per unit and K1 is the 30%, IS2 set as 3 per unit, K2 as 50%. Here each S2 and each S1 both disabled, and second harmonic block is enabled, and IS second harmonic greater than must be 15%, that is during charging of the transformer. If the relay see the more than 15% of second harmonic contact in the charging current, it will block the differential characteristics and allow the charging. Cross blocking has been enabled in this relay, and fifth harmonic block enable, which is set as 25%, that is during charging of the transformer, if their content 25% more than 25% fifth harmonic current, it will block the differential characteristics. These are the main point for setting of the Micom P643 differential protection. Now we put the settings in the characteristics The characteristics looks like as shown in this diagram. Here point 2 is the initial setting for ID, that should be get ID should be must be greater than 0.2 for a range of I bias for 0 less than I bias less than 0.67, and from I bias greater than 0.67 to up to a range of 3, the ID must be greater than the slope 30% slope to remain in the operating region, otherwise it will not operate. If I bias is greater than 3, then it will ID must be greater than 50% region for relay to trip, otherwise it will remain in restraining region. And I set high set must be greater than here high set is disable. You can give high set value as HS1, that is 8 to 10, and HS2 is 12 to 15, whatever you choose. Now Micom P643 is tested from a test kit, that is a current injection kit. First we have to give the stable current, that is, since the rating is 50 MVA and HV rating is 132 kV and LV voltage is 33 kV, HV full load current is 875 ampere, that is the secondary current is 0.875 on full load, and secondary current on HV is 0.73, as CT ratio is 300/1. We give the full load current in the both HV and LV side in secondary form, and to see check whether the system is stable or not. To see the current in the measurement menu, you have to go to measurement 1, and then you can see the A phase, B phase and C phase current on HV as IA1, IB1 and IC1. Similarly, for LV side, you can see the current IB, IC, IA3, IB3 and IC3 phase current. Initially, we will test for ID greater than 0.2. Initially, we will give only the primary side current, that is secondary current of 0.146 ampere current in each phases. That is, during the charging of the transformer, only primary current exists. It should not trip during charging of the transformer. Therefore, a ID is given, minimum ID is given 0.2 per unit. Since 0.146 ampere current is given in the secondary side, it will give the ID as a 0.2 per unit. Since ID is 0.2 per unit and I bias is less than 0.67, therefore relay will tripped. If ID is this current is lesser, then ID will be lesser and relay will not trip. Now for the region that is starting I bias is greater than 0.67 but less than 3, and the slope must be greater than 30% for belonging in the tripping region. Now suppose we consider this ID is 0.2 but an I bias is 0.67 in the boundary region where the 30% slope start. Therefore I1 plus I2 by 2 is equal to 0.67 and I1 minus I2 is equal to 0.2. From there we can calculate the per unit current in the HV side is equal to 0.77 and I2, that is in LV side, is 0.57. From there we can get the secondary current for HV is equal to 0.5621 ampere and secondary current for LV equal to 0.49875. It is the boundary current when both the current is exist. Beyond that current, that is if the HV current is increases or LV current decreases, it will remain in the 30% slope region. Otherwise it will remain in the less than 0.67 I bias region, where ID must be greater than 0.2 for relay to operate. Now we can see that 0.562 ampere in the secondary side the HV current has been given, and 0.499 current ampere has been given, which result as a 0.2 per unit of the ID, and I bias is 0.67. Relay you can see the current IA1, IA2 and IB1, that is HV current, and also IA3 and IB3 and IC3 in the measurement 1, and in the measurement 3 you can see and the ID, IAD and IBD and ICD differential current in per phase basis, and the bias current in per phase basis IA bias and IB bias and IC bias in the measurement 3 menu. Here since here ID is greater than 0.2 but I bias is greater than 0.67, slope remains in the below 30% region, that why relay will not trip. Now in the injected kit we have given current in the primary secondary side in the HV as a 1.314 current, which is equivalent to 394.2 ampere, and in the LV side we have given a current of 1.138, that is 1138 ampere current, which result as a I1, that is per unit current in the HV side as a 1.8 per unit, and LV side the per unit current comes to as 1.3 per unit. Therefore the ID comes as a 0.5 per unit, and I bias comes as a 1.55 per unit, and that is if we divide it by ID by I bias, which comes to as a 32%. Since it is a slope of 32%, that is beyond 30% region, the relay will operate and relay will send a trip signal. For 50% region we have to calculate the point AB and OA for calculate the actual slope. For 50% region the slope must be ID by I bias minus 1.2 greater than 0.5 for relay to be tripped. Now for 50% slope, if we extend it backward from point C, it will meet the x-axis at point A. Now since OB is equal to 3, we get as a 30% slope BC is equal to 0.9. Since BC is equal to 0.9, if we extended the 50% slope in the backward side, which meet at the x-axis at point A, we get the value of AB as a 1.8. Therefore the value of OA is equal to 1.2. Therefore for 50% region the slope must be, that is if for a given value of I bias, ID by I bias minus 1.2 must be greater than 0.5 for relay to operate, otherwise it will remain in the restraining region. From the set we are given the secondary current for HV as a 2.519 ampere, and for LV we have given 2.231 ampere, which is equivalent as a primary current for HV side as a 756 ampere, and for LV side as a 2231 ampere. Therefore the ID the per unit current in the HV side comes as a 3.45 unit, and for LV side it comes as a 2.54 unit. Therefore ID comes as a 0.9 per unit and I bias as a 3 per unit. Since ID by I bias minus 1.2 comes as a greater than 0.5 or greater than 50% slope, relay will give a trip signal or relay will operate. So you have watched my videos regarding the basic testing of the differential relay. Thank you for watching my videos.